Alright, we're back for the second page of the dosage practice problems, and this page is different. There's 5 problems on this page, but for these problems I'm interested in you thinking about the problem a little bit deeper. So I want you to do the math, but in addition to that I also want you to think about if the dosage that has been prescribed, it makes sense. Does it make sense? For example, we wouldn't want to give a toddler 21 pills of something, or 50 milliliters of some medicine. Okay, so you have to think about, did you do the math correctly? But in addition to that, you also need to think about, does the dosage make sense as it is prescribed? People make mistakes. These kinds of mistakes are pretty rare as far as coming from a doctor's prescription, but they're still possible, and I still want you to be able to think about these problems from a logical, sort of common sense standpoint. So that's what this is aimed at, more of a critical thinking type problem. Alright, so let's begin with number 1. And there's a lot of numbers here and a lot of units, and we're going to go through each one and hopefully break this down in a way that makes sense. So the first thing that I'm going to do for these problems is to actually write out what we're given over here on the left. So the weight of the patient is 40 pounds. The dosage as given by the doctor's order is 200 milligrams per kilogram per day. So this is how you would take this series of fractions and incorporate it into sort of a more top and bottom type fraction, as opposed to one read horizontally. And then finally, the concentration of the drug is 125 milligrams in 5 milliliters. Okay, so this one is a little bit different than some of the problems we saw on the first page where there was just milligrams per milliliter. Here it's milligrams per 5 milliliters. Okay. And just for reference, 1 teaspoon is 5 milliliters. Okay, so this could also be transposed into being milligrams per teaspoon. All right, so just like the problems that we saw on the other page, we are given a dose. We're given the fact that this particular medicine is given over the course of 4 divided doses, so every 6 hours. And we're given the patient's weight. So we're going to begin there with 40 pounds. And then the next thing we're going to do, because this is milligrams per kilogram per day, we need to convert into kilograms. So we're going to do 2.2 pounds, convert that into kilograms of body weight. And then the next thing we're going to do is use our dosage. Whoops, it does not go there. This is 200, goes on top, milligrams per kilogram per day. So you can put a 1 here, kind of give you a number to associate with for the denominator, but this is 200 milligrams are given for every kilogram of body weight for every day. Okay. Now we need to actually break this down into doses, individual doses, to kind of get a better sense of how much is given each time the medicine is dispensed. But before we do that, we need to convert it into milliliters. So we take this 125 milligrams and then put 5 milliliters on top. I'm going to go ahead and walk through how everything cancels out so far. milligrams canceled out with milligrams, and we have, at this point we have milliliters per day. Okay, milliliters per day, but I actually want to get, like I said, even more close-up look. I want to get milliliters per dose. So I'm going to put 1 day up here to cancel out the day, and I know that there are 4 doses in each day. So now I've got milliliters per dose. And I could even take it one step further and use this calculation here and go all the way to teaspoons, just to give it more of a relevant type reference point. I think we all know what a teaspoon is, and that's a little bit easier to think about instead of milliliters. So now we have our units, teaspoon per dose. And when we do all of this math, okay, if we divide by 2.2, multiply by 200, multiply by 5, divided by 125, divide by 4, and divide by 5, we get 7.27 teaspoons per dose. Okay. Now a 40-pound child, that's a 4-year-old. Would you give a 4-year-old 7 teaspoons of anything in one dose at one time? And hopefully your answer is no. That just seems like too much to give to a little child. Okay, so common sense would say that there's something wrong here, that 7 teaspoons just seems like too much to be giving to a 4-year-old. Okay, so something is wrong with this. We don't need to figure out what it is, we just need to say that no, this does not make sense. Okay, and this is the evidence of that. Too much medication has been prescribed. And this would be the point where you would want to double check your math, double check with supervisor just to make sure that, hey, is this actually correct? Chances are they're not going to have you given a 4-year-old that much medication. All right, next problem. A 55-pound child is prescribed 7 milligrams per kilogram per dose of ibuprofen to be taken every 4 to 6 hours. The available suspension contains 100 milligrams per 5 milliliters of solution. I've given you that same reference. 1 teaspoon is equal to 5 mils, so you can just think about it in terms of teaspoons. So with this one, we're just thinking about this in terms of doses. We don't need to use this 4 to 6 hours for anything. Okay, this is just saying that this is the typical time period where you would want to give a dose every 4 to 6 hours. We're just going to calculate for 1 dose. How much is prescribed for this 1 dose, not per day or anything like that. 55 pounds. Got to do that first conversion. 2.2 pounds to 1 kilogram because our doses is in terms of kilograms. And then we use that 7 milligrams for 1 kilogram per 1 dose. Okay? Cancel out the units. So at this point we're left with milligrams per dose, but it's kind of hard for us to conceptualize whether a dose is correct in terms of milligrams, so we're going to go ahead and take this to teaspoons. 100 milligrams. I put that on the bottom so I can cancel it out, for every 5 milliliters of liquid, and then finally converting this into teaspoons. Canceling out my milliliters, so I'm left with teaspoons per dose. Those are the only 2 units that are left over. And when you do this calculation, you end up with 1.75 teaspoons. Now that seems a little more reasonable. Seems a little bit more reasonable that you would give a child even a older child than the last problem, about 2 teaspoons of this medication. That seems more reasonable. All right, next problem. The doctor hands you a prescription that reads 50 milligrams per kilogram per dose of acetaminophen. Your patient is a child that weighs 50 pounds. That's about a 5-year-old. The available medication are junior tablets that contain 160 milligrams per tablet. Now we're talking about tablets, no longer talking about liquid that you would draw up with a syringe and kind of inject in the mouth or give it to them as a cup. We're talking about actual tablets now. So let's begin with 50 pounds, just like we have in the last several problems. 2.2 pounds per kilogram. Again, we're doing that because there's our doses in terms of kilograms. 50 milligrams per kilogram per dose. Cancel out pounds, cancel out kilograms. Now we're left with milligrams per dose, but again, not interested in milligrams. I want to know how many tablets is that. There's 160 milligrams in one tablet. I know to put milligrams on the bottom so I can cancel it out from this unit up here. Now I'm left with tablets per dose. When I do that calculation, I end up with 7.1 tablets. Now, would you give your 5-year-old 7 tablets of anything in one sitting? I hope not. You would probably want to check with somebody before doing that, but it sounds like too much to me. I'm going to go ahead and say too much. All right, a couple more problems. A 175-pound patient is prescribed 5 milligrams per kilograms per dose of morphine every 5 hours. The available medication comes in a suspension that contains 10 milligrams of morphine for every 5 mils of solution. You are to administer the solution using a syringe into an IV line. All right. This one may be a little bit more difficult to think about, but I think when we get to the answer, you will hopefully see that the number is a little bit outrageous. I'm going to go ahead and tell you that this one is going to be too much, but let's show you the math on it. We're trying to get to milliliters of solution, milliliters of this morphine solution. Okay, you know that because you're going to administer it using a syringe into an IV line, and you would do that in the liquid form, and milliliters is a measure of volume. So let's go ahead and begin. But where do we begin? This one looks like there's a lot of numbers and things, but I know that I can start with the patient's body weight. Let's go ahead and write out the givens for this one as well, just so we're clear. 175 pounds is the weight. This is the dosage. 5 milligrams per kilogram per dose. And again, we could write that like this: 5 milligrams per 1 kilogram per dose. Same thing. And then finally the concentration of that liquid. 10 milligrams for every 5 milliliters of that solution. Okay. So we're going to start with the patient's body weight. Do the same thing we've done before, pounds to kilograms. This is probably seeming very redundant, but a lot of these problems start off the same. Next thing is that dosage. Go ahead and prove to myself I've canceled out all the units that I want to at this point and left with milligrams per dose. Now I can incorporate that concentration. 10 milligrams, 5 milliliters. Going to cancel out the milligrams there. And I'm done. That's all the information I'm given. I don't want to take this to teaspoons because it's going to be given to the patient in a syringe into an IV line, not by mouth. So you don't want to convert this to teaspoons. And when I do all the math here, here's what I end up with. 198.8 milliliters. Now, just to give you some reference here, normal syringes volumes are 10 to 12 milliliters. So this would be almost 20 syringe loads. That would kill somebody pretty quick, especially of morphine. So definitely way too much. And of course, after you have experience with syringes and things, you would know right off the bat that's way too much volume to be given anybody. So something is wrong with the prescription as it reads. All right, next one. Prescription was written for a 95-pound patient that reads 50 milligrams per kilogram per day, where half of the dosage is given in the morning and the other half in the evening. So this means that every day 2 doses are given. The drug is sold in 100 milligram tablets. Okay, so let's go ahead and begin with the patient's weight. And again, pounds to kilograms, and then the kilograms to the dose. I'm going to go ahead and take this to, for every 1 day, there are 2 doses. Okay? Because 1 dose in the morning, 1 dose in the evening. Cancel out kilograms, cancel out days. Now I'm left with milligrams per dose. And let's go to tablets. So I'm going to put 100 milligrams on the bottom so that I can cancel out that from the numerator. And that's 1 tablet. So if I see what I'm left with, I'm left with tablet per dose. Okay. And if I do that, do the math, I should get 10.8 tablets per dose. Once again, seems like a lot, okay, for anybody. And so I'm going to go ahead and say that that is too much medication. Okay. Alright, so I hope this video was helpful in kind of thinking about some of these problems, not just from a mathematical standpoint, but also from a sort of a common sense, logical standpoint, looking at real life examples of, maybe you're handed something and asked to calculate the dosage, and then you find that something is wrong with it. And that could be obviously something wrong with your math, something wrong with your calculations. And that's a good indicator to go back and check yourself, which you should always do. But it could also be that it was written incorrectly or you read it incorrectly. So anyway, alrighty.